cat and dog problem, of course, when I'm trying to make a video. I knew I should have done this in the car. But anyway, what we've got here is the number of moles is equal to the grams divided by molar mass, because I only gave you grams. So 36 divided by 12, the molar mass, you always have carbon, which is equal to 3 moles of carbon. All right, now going back to this one, we found 3 moles. Now you got to jump it over here. And so basically I'm asking you to do 2 steps for one question. And what you do, number of atoms is equal to moles times Avogadro's number, which is 3 times that, which is 1.8 times 10 to the 24. So there are, in 36 grams of carbon, there are 3 moles, and there are 1.8 times 10 to the 24 atoms. Next question, what is the mass of 3.01 times 10 to the 23 atoms of lead? Okay, try these out. These are exam questions. I'm just going to change the numbers. Okay, and how do we do this one here? That is slide number 17. That is the next one. Where did that go? Okay, and here is a step-by-step of it. What is the mass of 3.01 times 10 to the 3 atoms of lead? What did I give you? What am I asking for? And you just solve away. All right. No, I don't want that. I want that. 1 gram of which of the following elements would contain the largest number of atoms? So you look at this, 1 gram of nitrogen, 1 gram of hydrogen, 1 gram of phosphorus, and 1 gram of oxygen. Which one would contain the largest amount of atoms? Well, whichever one has the smallest molar mass. Okay? The 1 mole, they're all going to be the same number, 6.02 times 10 to the 23 atoms. All right? But it's about how much each atom weighs. And hydrogen has an atomic mass of 1. All right, so it's going to weigh the least. And you have a look here. Okay, 1 gram of nitrogen, okay, has this amount of atoms. 1 gram of hydrogen has this amount of atoms. 1 gram of phosphorus has this amount of atoms. So just to recap, if you're comparing 1 gram of each of these, okay, and you want to know which one would contain the largest amount of atoms, well, you have to go for the smallest molar mass. Okay. Conversely, nitrogen has a molar mass of 14, hydrogen 1, phosphorus 32, oxygen 16. Which one would have the least amount of atoms? Well, you have to go with the one that has the largest molar mass, which would be that one there. Okay. Now, going back to this one here, sorry, just jumping around. Nitrogen has a molar mass of 14. Where'd you get that? Periodic table. Okay. Hydrogen 1, phosphorus 32, oxygen. So these are the molar masses of atoms. What about for compounds? Like look at CO2. How would you figure out the molar mass of CO2? Well, probably you've already figured it out. You just add up the molar mass of each one of these. So you see carbon. How many carbons are there? There's 1 of them, and it has a molar mass of 12. Oxygen has a molar mass of 16, but there are 2 of them. So that'll be 32. All right, and you add them all up and you get 44. This is the molar mass of a compound. All right, so here's a good exam question. I think this is in the assignment as well. What is the molar mass of aluminum carbonate? So what do we got? How many aluminums? 2 of them. What's the molar mass of aluminum? 26.98. How many carbons we have? 3 times 12. How many oxygens we have? 9 times 16. Add them all up, you get 233.99. Okay. What is the molar mass of ammonium phosphate? This one here, I like it because it makes you count. How many nitrogens do we have in here? Did you say 3? Good. How many hydrogens do we have? 12. Geez, I feel like I'm watching my kids Dora right now. All right. Phosphorus, we have 1. And oxygen, we have 4. So, did I put this one on this slideroo? Let me have a look here. What's that? 21? Okay. So, let's go to here. I don't know if I did or not. No, I didn't. Okay. So, you just add all these up and multiply by the number. Okay. You count how many atoms of each one you have. Okay. So if I have 12 hydrogens, and then you multiply by the molar mass. All right. Try those out. Try them out. Here's another one here. What is the molar mass of magnesium chlorate? Okay. You have 1 magnesium times its molar mass. You have 2 chlorines times its molar mass. And you have 8 oxygens times its molar mass. Should add up to 223. Okay. And don't worry. Maybe you're getting 223.14. Or maybe you're getting 222.9. Okay. Your periodic table might be different from mine. Okay. On your periodic table for hydrogen, if you check right now, it should say 1.008. Okay. On my periodic table that I have, it says 1.00797, which is basically the same number. Okay, we're off by 1/10,000. Okay, but don't worry about this because on the test, I'm not going to give you 2 answers that are insanely similar. Okay, you see how this one here is a bit high, 123.76. So basically, it's 124. You should be getting around 223, 222.9, somewhere in there. All right. But on a testing situation, there will be no problem in identifying the answer if you've done the correct mathematics. Okay, using your periodic table. So don't worry about that. Getting back to this one here. Here we're just gonna start playing with these guys here. These 2 formulas.
Yes, it's Superman.
That's. I gotta change that ringtone. But now you've got to be able to use both of these formulas interchangeably. So if I give you grams, ask for atoms, you can flip. Maybe next one here, I give you atoms and I ask for grams. Okay? Being able, the key to this is whatever information I give you, you've got to convert it to moles, jump it over, and go. So here we go. What do we got here? Calculate the mass of 0.15 moles of magnesium chlorate. So what am I asking for? Mass. What did I give you? Moles. All right. So I only need one formula because there's only one formula that has mass in moles. This isn't a bad one. All right. I'm only going to use one formula. So grams is equal to moles times molar mass. I gave you the moles, okay, 0.15 times the molar mass. Now I said you always have the molar mass. You just go to the periodic table. But here now, you have to calculate the molar mass of magnesium chlorate, which means you got to add them up. And I got to add them up. When I'm doing molar mass calculations, I do them exactly the same way. Okay, and so here we go. We got this one here. Let's go on. Calculate the number of water molecules in 35 grams of water. So calculate the number of molecules. Okay, so now I'm looking for the number of molecules. Okay, that's one of the formulas. What did I give you? I gave you grams. Uh-oh, that's in the other formula. So what you have to do is you got to solve for moles and then substitute it into the other formula. Okay, going back to this one here. I gave you the grams, which was 35 grams. You have the molar mass, you have to calculate it. You're going to have to go to moles, substitute it in here. Now you have the number of moles times Avogadro's number will give you the number of molecules. Okay? And that's it right there. So the first step, moles is equal to grams divided by molar mass, 35 grams divided by 18 grams per mole. Where did you get that? You got to calculate. That's the molar mass of water. Okay, is equal to 1.94 moles of water. Number of molecules, this is the second formula now. Moles times Avogadro's number is equal to 1.94 times this gives you this. Okay, how many moles of glucose? Okay, C6H12O6 are present in 146 grams of sugar. So what am I asking for? I'm asking for moles. What did I give you? Grams. Okay, you only have to use one formula. So number of moles is equal to grams divided by molar mass, 146 grams. Molar mass of sugar or glucose, you have to add all these up, 6 carbons times 12, 12 hydrogens times 1, 6 oxygens times 16, add them all up, I think you get 180. Okay, and you do the math there, you get 0.810. Again, what is the mass of 1.2 times 10 to the 23 molecules of methanol? Okay, try and figure these out. You don't have to figure them out. You've got the answers. I think that we are on the end here. Where's 27? Right there. So that's how you do it. All right, so have a look at it, try it out. And the only way to do these is to just try them out, okay? And yeah, you're gonna flub this one here, but eventually you're gonna start to recognize how it all goes together. There's no other way to do these than to just try them out, okay? And this is what you need to get good at there this week, because next week is our last PowerPoint lecture. Okay, week 13 will be a kind of a free review week, which I'll give you a review package of questions and answers, these kinds of things. But this kind of a question is where you've got to be good at it, being able to flip in and out from one triangle formula to another triangle formula. All right, so let's continue on here. There's another one there. The answer is posted on, I think it's on page 4. Okay, have a look at those. To finish off here, something it's not a bad. This one here is not bad at all. It's called percent composition of compounds. So if you look here, sodium carbonate, and I'm giving you these there. Sodium carbonate is 43.38% by weight sodium, 11% carbon, 45% oxygen. But how did I get these numbers? Well, it's pretty easy to calculate. First of all, I need to determine the molar mass of sodium carbonate. Well, you've already got this skill. Okay, how do I make the molar mass of sodium carbonate? Well, there's 2 sodiums times 22.99 periodic table plus 1 carbon at 12 grams. Can't see that there. I don't know why that's coming out like that. There we go. I got 3 oxygens at 16. You add them all up, you get 105.99 grams per mole. So the molar mass of sodium carbonate is basically 106 grams per mole. Now, you're going to dissect this into 3 parts. You're going to dissect the sodiums off. You're going to dissect the carbon off. You're going to dissect the sodiums off. You're going to dissect the carbons off. And you're going to dissect the oxygens off. Okay? And how many sodiums do you have? You got 2. So 2 times the molar mass of sodium divided by the whole molar mass times 100% is 43. So that's how we know sodium is 43% of the weight or mass of this guy. Carbon, there's 1 of them, times 12, divided again by the whole molar mass times 100% is 11%. There are 3 oxygens here times 16 divided by the molar mass is 45%. And please note, this should always add up to 100. Always 100%. Or 99.9 because we're dealing with some decimals here to 2 or 3 decimal places. So what do we got here? A compound is found to consist of 2.74 grams of iron and 5.24 grams of chlorine. What is the percent composition of the compound? So I got 2.74 grams of iron and 5.24 grams of chlorine. What is the percent composition of the compound? Well, here, if all the iron weighs that, and all the chlorine weighs that, and if that's all there is, then the compound that we're talking about here is weighing 7.98 grams. That's the total mass. So now for the iron, take your 2.74 divided by 7.98 times 100. Therefore this thing is 34% iron. Take your 5.24 divided by the whole thing, 65% chlorine. Not so bad. What do we got here? What is the percent of carbon in acetic acid? Well, how would you do this? First, you'd have to find the total molar mass of acetic acid, which I think is 60. Okay? And then, how many carbons do I have in here? 2. So, and carbon has a molar mass of 12. 2 times 12 is 24. 24 divided by 60 is, sorry. I know the answer was on there, but I wanted to show you. Is that it there? Yes. So, what do we have here? Slide 31. What is the percent of carbon? There you go. There is the molar mass of acetic acid. Okay. There are 2 carbons. 24 divided by 60 is 0.4. Okay. Times 100% is 40%. Okay. Which is what we got right there. There is another question there. 6 grams of calcium sulfide is found to contain 3.33 grams of calcium. What is the percent by mass of sulfur in the compound? This one here, be careful. I didn't give you the chemistry. I only gave you the English. So you have to know what the chemical formula of calcium sulfide is. Remember this there from week 5. Calcium sulfide. Calcium 2 plus, sulfur 2 minus. Okay, it's an ide, 2 bananas, so it's ratio 1 to 1. CAS. So you have 6 grams of calcium. Okay, or sorry, a 6 gram sample of calcium sulfide contains 3.33 grams of calcium. So where is it here? Is that it? Yeah. And right there. That's how you do this one right here. And it works out to be 44.5%. Okay? That is it. I don't want to take up any more of your time. You have the review questions here. You have the paired answers. You have all the answers. And again, getting back into this one here, these are these extra questions there that I gave you. These ones are really good because it's practicing skills, bang, 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 which is what you want. It's repetition. So this one here, I'm just looking for the molar mass of all of these. Don't do them all, you know, but just practice doing a couple of them there so you get good at doing the molar mass. Like this one here, sodium sulfate. 2 sodiums, 1 sulfur, 4 oxygens, add them all up, bang, molar mass. It's all about skills building. This one here, determine the number of moles. So here, I give you grams. I'm asking for moles. Which triangle am I going to use? Practice a couple of these, don't do them all. Alright? And they're here. I'm looking for grams. I'm giving you moles. Which triangle am I going to use? And it's the same skill every time. So you're doing 5 in a row, bang, bang, bang. So you get good at it. Here, how many molecules are in each quantity? Well, here I gave you moles. I'm going to use the other triangle formula now to solve for the number of molecules. Bang, bang, bang. How many moles are in the number of molecules listed? So here I've given you the number of molecules. How many moles are in those? Determine the percentage composition. So here I've got potassium, I got manganese, I got oxygen here. You got to find the molar mass of this. So it would be the molar mass of potassium divided by the total molar mass of the compound times 100. Bang. And you've got all the answers here. Okay, so I think you guys are going to do great. Please try these out. Please become a master at these there by next Friday, because where we're going, you've got to be good at this to where we're going to be going. And next week is the last PowerPoint. It's a good one. It's a doozy. All right. But get good at this this week and keep working on your assignment. There are things on there that I haven't taught you yet, so don't do them. We're gonna get going on. I will post the PowerPoint early, but the video I'll probably post again next Friday or Saturday, and we have lots of time because next week is the last PowerPoint to go up, and that gives us time there, week 13, to just practice. All right, so you guys take it easy out there, be safe, be well, be happy, and we will chat soon, and please keep the emails coming. Okay, take it easy. Bye bye.